So wheat milling process, traditionally it was done with simple atta chakki having two stones, one is stationary and one is revolving, and this is being made to rotate with the hand manually. Manual rotation was there so that you can get the wheat flour, whole wheat flour. The input is equal to output. Whatever you feed inside the mill, you are going to receive that in the form of flour. But finally, you can receive so many products from milling. It can be wheat flakes, puffed wheat, shredded wheat, so many products. Shredded wheat is dalia, you can say. Now, in the milling processes, if I talk about traditional milling, this is done by stone grinding. The product you get is atta, which is having the extraction rate of around 90 to 95%. And in milling, some of the indigestible parts like cellulose, phytic acid, they are being removed, and phytic acid actually binds the minerals. So it's good that it should be removed so that you can get a good product in your diet. Then Indian style flours, it is not technically whole wheat because some of the portions like bran and germ are being removed. And traditional stone grinding, it is replaced now by power driven small and big chakkis, and now the replacement is being done with the modern flour mills. And this modern milling, it is a step-by-step process. Firstly, the grain is being cleaned. There are basically three steps which are involved in modern milling. The first is grain cleaning. Then the second one, very important, is tempering or conditioning. And the third one is roller milling, roller mill. So in cleaning of grains, you have to remove the wheat impurities, whether the grain is damaged, shrunken, the kernels they are broken, they are collectively known as screenings. And to remove the metal part or metallic part, magnetic separators are there. And milling separator, it is used to remove sticks, stones, and any other foreign materials. And this is based on the principle of aspiration, in which the air is being pulled through the grain, and when the grain it is being fed into the machine, the air is being pulled so that the lighter particles they move away and the heavier particles you are going to retain. And the grain is then fed into the sieve, which is larger in size than the desired grain, and the sieve it retains the desired grain but removes the smaller grains by allowing them to pass through. Then after cleaning, there are so many equipments being involved. Like if I talk about the sieve it works on the principle of reciprocation. That is, it is moving back and forth, whether it is mechanically or manually. And there are disc separators which separate the grain of same density from the desired grain. And this separation is actually based on the length of the kernels. Then there is a scorer which removes the impurities which are adhering to the grain. This is actually done by rubbing the grain itself or by a perforated metal screen or on any emery surface to remove the adhered dirt or dust. And when this dirt is being loosened, it is removed by aspiration. And this not only helps in the removal of dirt or dust, but it also helps in the removal of some of the wheat diseases which the wheat contracts in the fields itself. They are rust and smut. These type of rust and smut are also being removed through the scoring principle. Now, if I talk about the principles of separation of wheat cleaning, so they are the wheat cleaning, it is actually based on the size and shape of the kernels, the terminal velocity in the air currents which you are passing through during aspiration. It is also based on the specific gravity of the grains and magnetic and electrostatic properties. Then the color, on the basis of color, you can do separation, and surface roughness. So these were the 6 principles on the basis of which the wheat is being cleaned. And if I talk about the layout, because gravity is an important principle for separation, for cleaning. So if the layout is facilitated by installation of equipment over 4 to 5 floors, so that gravity can be used for wheat to fall from one machine to the next and then elevated and re-elevated. And the total amount of screenings which are removed, generally they account to 1 to 1.5 of the grain which is being fed into the machine. Now, the second very important step of milling is conditioning or tempering. This we had already discussed, that conditioning is done for the softening of endosperm to make the bran tough and to make the endosperm soft so that you can retain the maximum endosperm part during milling. So it improves the physical state of the grain for milling. And if I talk about definition, so you can define tempering like it is a process of addition or removal of water or moisture for definite period of time to obtain desired moisture content in the grain. And the desired moisture content is 12 to 14%. Now, why we do the conditioning of the grain? Why the conditioning of grain is required? The way you condition yourself, the way you condition your hairs, same ways conditioning of grain is required. There are three basic reasons for the conditioning of grains. Firstly, to toughen the bran so that a longer extraction of low ash content flour can be made. Secondly, to ensure that the moisture is being migrated to the endosperm and it can produce the flour of approximately 14 to 15% moisture content. And third, very important, is to mellow the endosperm so that it will be easier to remove the bran during milling. For the easy processing of milling, the endosperm is being mellowed. Now, how this first automatic mill has been developed? Actually, the first mills were hand operated. Those millstones were hand operated. And then the millstones, hands were replaced by animals. Then they were driven by animals. And then the animals were replaced by water power. And now we have come up with modern mills because this roller milling is required as our wheat grain is a complex grain. Complex because it is having a central crease that passes through the grain to achieve maximum amount of the grain in the milled form. We have to use this roller milling. Actually, the idea of roller milling, it was generated in Switzerland and later in Hungary, where the porcelain or steel rollers were used instead of millstones. Now, what are the advantages of roller mill? First, very important advantage is that the capacity of roller mill is much larger than the windmill or water mill. Industrially, if you have to mill a large amount of wheat grain, then this roller mill is very beneficial. Then you can achieve variety of products, versatility of products that fits to the needs of the industry. Whether you want to achieve refined wheat flour, semolina, shredded wheat, so many products you can obtain through roller milling itself. And this roller milling is less laborious and it is less time consuming. Now, how it actually operates. So the roller milling, it comprises of several grinding steps. There are so many grinding steps which are being followed by sifting operations. Basically, there are two systems of operation. One is the brake system and the second one is reduction system. They are based on the principle of gentle grinding and intermediate sifting or sieving to develop break purification, develop the breaking of the grain, then purification of the flour, and then reducing the flour further to a fine powder. So in this image, you can see there are two sets of rolls. One are the break rolls and the second pair of rolls are reduction rolls. The grains are being fed from here in this hopper and they are being contracted by this break roll. It is a corrugated roll where the grain is being fixed into these corrugations and it is crushed here. So the brake system actually helps in the crushing of the grain. And then the crushed grain, it passes through the reduction system, reduction rolls. These rolls, both the rolls, they are rotating in opposite direction. And this crushed grain is then passed. Here the sifters are there, and then after sifting, the fine powder is passed through reduction rolls to further help in grinding. So it is actually based on the principle of gentle grinding with several grinding steps followed by sifting and then again reducing. So this diagram actually shows you a milling system comprising of 2 sets of break rolls and 3 sets of reduction rolls with the 2 sifters here and 3 sifters here after the reduction rolls. I'll be telling you how it actually works. So the variations, they were actually required in the process flow sheet because there was the requirement of perfection of gradual reduction system. I can give you an example here. British government, they ordered millers to produce high extraction flour rate during wartime in order to extend the supplies and to supplement the people's diet with essential vitamins and minerals which are found in outer bran layers. So the flour mill technologies, they were being developed, which included flow sheet alterations to accommodate new machine technologies. And even not to accommodate only new machine technologies, so as to accommodate the increasing capacities of the machines as well as the adoption of new information technologies in the milling system. Now I talk about the break rolls. Break rolls actually, they help in the virtual separation of bran and endosperm. Break system or break rolls, they consist of 4 to 5 sets of rolls which are corrugated or having fluted iron rolls, and they operate in pairs. There are 2 pairs and then they revolve in opposite direction. There are 2 rolls and they work in pair and they revolve in opposite direction, and the differential speed of these 2 rolls, they varies. It is in the ratio of 1:2. If the one roll is rotating at a speed of 1 and then the second one is going to rotate at the double speed, this way they rotate actually. So this was all about the brake system. I'll stop my screen sharing here only.